Today we'll study the first FRQ from the 2015 exam, and right off the bat it was a problem about rates of change. Rates of change are legendary. It's pretty hard if you remember when we had ladders sliding down the walls or people walking in the street and their shadow is growing or decreasing in length. However, it's not too bad doing FRQs because the exercises very much look alike all the time. We can really predict what the questions are going to be, and if we're prepared, if we've reviewed previous exams, we can do really well. This one was a calculator active exercise, and there's 2 calculator active problems in this 2015 exam out of 6 problems. The mean of all the FRQs was 3.71. The mean for this exercise was 3.42. So not much below the mean. And I think that comes from the fact that students recognized this exercise. They had seen it before many times, so they knew how to solve the problems. 16% of all AB students earned a 0, however, and I think these students just didn't review enough, didn't look at previous exams enough to recognize what this question was. So let's read the question first. The rate at which rainwater flows into a drain pipe is modeled by the function r, and we can see that r is in cubic feet per hour. Cubic feet per hour, so it is a rate of change. And then let's continue. T is measured in hours between 0 and 8. The pipe is partially blocked, allowing water to drain out the other end of the pipe at a rate modeled by the function d, also in cubic feet per hour, also for t between 0 and 8. There are 30 cubic feet of water in the pipe at t equals 0. So it looks like the pipe is a little bit blocked. There's 30 cubic feet in there, and there's water coming in at this rate, and there's water coming out at that rate. So if one of the questions was, and we know it's going to be a question about how much water is in the pipe or how much water is coming in the pipe, we know that if we need to use these functions, we're going to have to integrate, because cubic feet per hour is a rate of change. So if a question is about cubic feet, we need to integrate. Let's see first what this situation is like, and whatever, this time it's a drain pipe, sometimes it's a tank, sometimes it's a theater with people coming in and people coming out, but it's always the same pattern. So here we have water coming in at this rate, and the units are cubic feet per hour. At the other end we have water going out at that rate. It's also in cubic feet per hour. And we have an extra information. This is not a rate. There is 30 cubic feet at time t equals 0 in the pipe. Question A. How many cubic feet of rainwater flow into the pipe during the 8-hour time interval 0 to 8? So we notice immediately that this question asks us something about cubic feet, so we're going to have to integrate r or d. Let's read the question again. How many cubic feet of rainwater flow into the pipe? They don't ask us about water going out. We're just wondering how much water goes in. So we're going to use R, and it doesn't matter either how much water was in the pipe from the beginning. They just ask us how much is coming in. So we're not going to use 30 cubic feet either. When we identify the units, we almost know for sure what we have to do. We're going to integrate from 0 to 8 this function r of t. So that's what the first student did, and the first student in these sample students always get maximum credit, so we can always use the first student as an example of what to follow. So the student integrates r of t dt from 0 to 8, then they copy what r of t is. You don't need to do that, and using the calculator finds 76.570 cubic feet. So the student even writes a sentence. During the 8-hour interval, about 76.570 cubic feet of water flow into the drain pipe. 2 points, one for writing the correct integrand r of t, so choosing the right function, and one for the answer. Second student. The second student integrates from 0 to 8 of 20 sine t squared over 35 dt, so the correct function r of t, and gets the same answer with a lot of decimals. That's fine if you have too many, but make sure that you have at least 3. I would just recommend to stick to 3. But that also is 2 points. The student got the right integrand and the right answer with units. Student 3 didn't integrate, so that student didn't pay attention to the units. He just or she just looked at r of 8, which is a rate of change. So this answer here is in cubic feet per hour. How could it answer a question about cubic feet? There's no way it's going to be correct. And that student got 0 point. So to interpret this answer, 19.3392 is the rate at which rainwater is flowing in the drain pipe in cubic feet per hour. Question B. Is the amount of water in the pipe increasing or decreasing at time t equals 3? Give a reason for your answer. I like to think about it in terms of comparing r of t and d of t. If r of t is bigger than d of t, then the amount of water is going to be increasing. On the other hand, if d of t is greater than r of t, then the amount of water is going to be decreasing. So let's look at what students did. Student A didn't study r of 3 and d of 3 separately, but he subtracted them, so r of 3 minus d of 3 here, and he's going to figure out whether this value is positive or negative. What's really good of that student is that he or she defined a new function t of x. It's something you can do, and it's going to save you a lot of time, and it's going to make your work very clear if you do that correctly. So the student defined a new function. The total amount of water is t of x. Therefore, he looks for the rate of change of t of x, t prime of x, and that's the rate r of x minus the rate d of x. And then he calculates the value at t equals 3 or x equals 3 and finds that it's negative 0.314. And he concludes, observing that this is less than 0, after 3 hours the amount of water in the pipe is decreasing because the derivative of the amount of water is less than 0 at 3 hours. So that's perfect. You earned 1 point if you compared r of t and d of t, and you earned 1 point if you gave a correct explanation for your answer. You can't just say decreasing, you have to explain it. This is student 2, and I personally prefer their work. However, we should look at this first. So student 2 looked at the rate at which water was flowing in at t equals 3 and found this value, and then the student looked at the rate at which water was coming out, found that, and noticed that 5.4 is greater than 5.08. Therefore, they concluded at t equals 3 hours, r of 3 is less than d of 3, so the amount of water in the pipe is decreasing. So 1.4 the answer, and 1.4 comparing r of 3 and d of 3. Student 3 looked for r of 3 and found 5.08. Looked for d of 3, there's a little mistake here, and found 5.4. The student didn't write units, but it seems like the FRQ graders thought this was not essential in this question. Conclusion, the amount of water in the pipe is decreasing at time t equals 3 hours because the rate at which the water is draining out the other end of the pipe is greater than the rate at which the rainwater flows into the drain pipe. That's a great answer. 2 points, so maximum score on question B for all students. Question C, this is where it becomes a little bit more difficult. At what time, between 0 and 8, is the amount of water in the pipe at a minimum? Justify your answer. Student 1 had defined the amount of water in the pipe as function t of x, and now he's using this function again. He wants to find, we need to find three things, remember, when the derivative is equal to 0, where it's undefined, and we have to check the endpoints. So using their calculator, the students find that the derivative is 0 at t equals 0 and at t equals 3.2716584. This is something you might understand now, but you absolutely have to try these kind of exercises with your calculator. You want to be very confident about what you're doing on the test, so you want to make your mistakes and ask your questions before the exam. So even though this seems easy, make sure that you can find this value 3.2716584 on your own. Then the student writes that the amount at time t equals t is t of 0 plus the integral from 0 to t of t prime. We're going to talk a little bit about this, but first just let's study it. Let's try to think about what this means. This is the amount of water that is going to be or change in the pipe between 0 and t. So it's going to be a positive value if there's more water, and it's going to be negative if there's less water. And to that, we have to add how much water we had from the beginning. So there was 30 cubic feet, and then we're going to add how much it has changed. But let's see how the student wrote that. Going back to the fundamental theorem of calculus, if you integrate a function from a to b, it's going to be the integral of b minus the integral at a. So in this example here, our function f of x is actually t prime, and our integral is actually t. And we're not integrating from a to b, we're integrating from 0 to t. So I just rewrote exactly the same thing, but with the letters and variables that we have in this specific FRQ. Now what do? You can add t of 0 on both sides, and you get t of t equals t of 0 plus integral from 0 to t of t prime of t dt. So this is what the student did. And then he substituted t of 0 equals 30. So that's how you come to this expression that you'll see very often in FRQ solutions. There's a little bit of an issue with this student here. You should not have the same variable up here that you have here. Anyway, the student earned 1 point. So now the student found, using the function that we just saw with the integral, that the amount of water at 3.272 is 27 cubic feet. The student looked for the amount of water at the endpoint. So at t equals 0, it was given. We know that it was 30 cubic feet. At t equals 8, the student had to use the function he found again, so 30 plus the integral from 0 to 8, etc. And he found that it's 48.544. So let's see what he wrote. After testing all critical numbers and endpoints for their values, the amount of water in the pipe achieves a minimum value of about 27.965 after about 3.272 hours. So he just compared these three values. These are three candidates. He doesn't mention places where the functions would be undefined, but there is none, so that's perfect. So 1 point for considering the three candidates, and 1 point for the answer. The second student was probably confused with this exercise and just didn't do anything that was correct. Tried a number line, but a number line is never going to be enough. A number line helps you, but you always have to write an explanation using words, and words that include some calculus. The last student wrote only this, but that earned him or her a point. The student is actually here looking for, this is R of 3, and this is R of t, and this is D of t. So the student is actually looking at when there's a balance between the amount coming in and the amount going out. And this is exactly what we want to look for. This is when it happens that we could have a maximum or a minimum. If the amount of water coming in is exactly equal to the amount coming out, where we may be reaching a maximum or a minimum. So the student got 1 point for that. Unfortunately, they didn't solve the question. This is something you have to solve with your calculator, so it's a calculator exercise. Do not try and solve it by hand. You just need to know how to use your calculator. Question D. The pipe can hold 50 cubic feet of water before overflowing. After t equals 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write but do not solve an equation involving one or more integrals that gives the time w when the pipe will begin to overflow. Student 1 is still benefiting from having defined the function t of x at the beginning, which was the total amount of water in the pipe. So now he can very simply write that what we are looking for is when the total amount of water is equal to 50. Because he also figured out what t of x was in question B, he can use that again and replaces t of w by 30 plus the integral from 0 to w t prime of t dt. This here solves his problem. He had a t and a t. Now, thanks to the w from the question, he doesn't have the same problem as before. This is an accumulation function, so how much is accumulating in the drain pipe and when will it reach 50? So you could just leave the answer like that, it would be correct. That student subtracted 30 and got 20 equals this integral, and that's all you have to do. It says do not solve, just write an equation involving one or more integrals. So the integrand here is correct, and the full equation is correct, so there are 2 points earned in this exercise. The second student gets the correct answer as well. He takes more risks in a way because he copies the entire expressions where you could just write r of t dt minus d of t dt and you would be right. But this is the correct answer. So just look at it. He wrote it into 2 integrals instead of 1. That's fine. This is basically 30 plus the amount coming in minus the amount that came out equals to 50. That's what we're looking for. So 2 points for that student as well. So common mistakes. Most students found parts A and B easier than parts C and D. And in part B, many students knew to consider R3 minus D of 3, or just R3 and D of 3 separately and then comparing which one is bigger, but did not properly communicate the difference. In part C, many students simply announced t equals 3.272 without a supporting mathematical equation. In addition, many students did not provide sufficient justification for the minimum value, so just showing a table of value is not going to be enough. Some students rounded intermediate values, and some students made decimal presentation errors. So let's talk about that a little bit more. Many students did not provide sufficient justification for the minimum value. This could also mean that the students found 3.272, but they didn't check the endpoints. So the correct answer happens to be t equals 3.272, but you won't earn all the credit if you don't also check what the endpoints value is. If you rounded the intermediate value t equals 3.272, probably your final answer is going to be wrong. It's not going to be rounded correctly. So when you find intermediate steps, like here, you want to keep t equals 3.272 and at least 5 or 6 decimals. Even better, store it in your calculator. In part B, some students simply miscalculated either R of 3 or D of 3. And some students solved this problem using the calculator in degree mode rather than radian mode. So that's a total disaster. You lose so many points. Make sure that you have your calculator on the exam and stop sharing your calculator a few weeks before the exam so that you don't have someone who goes to degree mode without you realizing it. We always use radians in AP Calculus. In part D, some students used an incorrect initial condition or no initial condition, so that means they forgot the 30. Many students used constant limits or no limits of integration, and some students omitted the differential dt. So if you forget dt, they can be lenient sometimes, but if it makes something wrong with your expression, then they're going to take points off. So in this case, if the initial condition was after the integrand was not well defined. What they mean is if you wrote integral of what we had plus 30, then you got the wrong answer, or you got the wrong expression. Now, a few recommendations from AP about this exercise. Teachers should stress the importance of correct and consistent notations. In problems involving an integral, the differential must be included, so that's dt. The differential must be included to indicate the integrand. In addition, mathematical expressions must be grouped properly, and parentheses must be used properly to convey the exact meaning of an equation or integral. In a calculator active questions, students should be encouraged to store functions using calculator functions names. You can also store values if you find the point of intersection of two functions, or if you find where something is 0, then you can store these values with all the decimals in your calculator. It's a good idea. These stored defined functions can then be used when the calculator is needed for evaluating mathematical expressions and performing computation. In addition, teachers should remind students to use the names of the given functions, such as r and d in this problem, in their work to avoid copy errors. The functions here and in other exercises can be pretty complex, and so if you make a writing mistake, you could be sorry. Students need more practice with rate in, rate out questions. Water flowing into and or out of a tank or pipe are common applications, and students should be familiar with the concept of the integral as an accumulation function. So we'll do lots of these, and you really need to recognize that the questions follow a similar pattern every time. It is also important for students to remember that if they use the calculator for one of the 4 required capabilities, they must indicate the mathematical setup, so the equation or integral. You can't just write an answer without anybody knowing where you found that, so you have to write an equation with an integral here, and then write the answer that you found with your calculator. That's it. Thank you very much. I hope that helped.